Hello everybody. Today I'm going to show you how to use the Whitespace programming language. Due to the esoteric nature of it, it's never really used to be practical, but it was just too fun not to make a video about. The reason is, if you actually would look at a program and look at the commands within the program, everything is invisible to the human eye unless the characters are highlighted. Because the only characters used in the entire language are spaces, tabs, and line feeds. Or these are just new lines. And instead of denoting each of these three things with the actual space or tab or new line, which would look something like this. It's much easier just to write the letter for what it's representing. So this is just what that would look like in much simpler terms, so it's what we're going to go with. So how does a command actually work in this language? Well, every command has 4 components. First, you have what's called the IMP, or the instruction, modification, parameter. With only 3 characters, you can't expect a language to do very much. And what the IMP does, or instruction modification parameter, does, is it just tries to broaden the amount of commands that it can do by saying that you have 5 types of commands. And the first part of every full command in the language has the IMP. And within every IMP, there are more commands you can do. So just think of it as a way to widen the functionality of the programming language. So then you have the actual command specific to the IMP. You might have something like add, push to the stack, end program, stuff like that. Then you have the parameters for the command. And a lot of times the parameters will be a binary number. I think that's the only thing we're going to be showing in this video. So usually a binary number. But how do we actually represent binary numbers in this language? Well, we only have 3 characters, right? So it takes a little bit of creativity, but what the creators did is they decided to represent every binary character with a character from the Whitespace language because, I mean, there's no other option. So binary numbers they have 0s and 1s. So in Whitespace, they just arbitrarily decided that tabs would be 1s and spaces would be 0s. But with only 3 characters, we'd have to have a way to actually decide when the binary number ends. Let's say you have a command that looks like, or you have a binary number as a parameter, where the IMP looks like that, the command looks like that, and then you have the binary number. I'm just going to write a random one right now. And then you actually go to the next command. Well, since line feeds are new lines, the next command would start right here. But the computer doesn't know where the binary number ends and where the next command begins. And so the creators used the last remaining character in the Whitespace language to represent the end of a binary number. And that would just be line feed. So binary numbers are very simple in this language. They always end with line feed. So when you think of a binary number, just remember tabs are 1s, spaces are 0s, and they always end with a line feed, and you'll be good. So now I'm going to go into the different types of IMPs. There are 5 different types, each doing something different. They're pretty simple, so it's not going to be too bad. So you have the IMP, and since there are 5 types, I will represent it visually like this. And after every IMP, you have the commands specific to it. So after you do that, each IMP has different branching commands that it can do. And think of these branches as doing something like adding, subtracting, pushing or popping from the stack, and stuff like that. So the first IMP is the stack manipulation. IMP. And this is just denoted with a space. And commands for this might be push, pop, and stuff like that. We're really only going to be using the push for now, but if you want to use more of the Whitespace functionality, then you can look up their website on the Wayback Machine, because they took it down a few years ago. The next one is arithmetic, which is denoted by a tab space, and this is just stuff like add, subtract, multiply, stuff like that. We're not going to really be using that today because we have no need, but you definitely can. The next one is heap access, and this is just for storing and retrieving data, and it's denoted with a tab. We're not going to be using this at all because we don't have any need to store data, but again, if you wanted to, you could. So store, retrieve, stuff like that. The next one, we can say flow control. This just deals with like the flow of the language, I guess. It's hard to explain, but it's denoted with a line feed, and the command that we'll be using isn't super necessary for every program, but it's always nice to do, like stuff like end program, just dealing with like the level of where you are in the program. And the final one is input output, denoted by a tab line feed. And this is probably the most important one that we're going to be using today, because it does stuff like print, and that is what we're going to be showing an example of. So if you'd actually look at the print command on their website, you would see that it only prints the ASCII representation of the binary number on the top of the stack. It's kind of a mouthful. So the first example is we're going to actually try to print something. We have a nice skeleton. We have I just showed what every command looks like. I showed the different IMPs you can do. So all commands will start with either a space, tab, line feed, or tab line feed. And now I will go over one example, maybe a couple. So, example. Just print a capital A. And, we don't have letters in the Whitespace language. We only have, 3 characters, spaces, tabs, and line feeds. But we also have binary numbers. And if we actually look at the print command of the IMP input output, it just prints the ASCII representation of the number at the top of the stack. And if you don't know what ASCII is, I'll give you a quick rundown. They're just numbers for every letter and every symbol that we have. So I think the number 0 is correlated to a space, and like 1 through 10 is a little above that, and I know that 65 is capital A. So A equals 65 in ASCII. B is 66, C is 67, and so on. But we don't have decimal numbers, so we have to represent this in binary. The way we do that is we just use the method that I just showed. So tabs are 1s, spaces are 0s, and line feeds end the binary number. So the way to represent this is a super easy binary number to represent because it's just 64 plus 1. So we can just start with space, tab, this is equal 64, 32, 16, 8, 4, 2, 1. And that is the binary number for 65 because this is, and obviously a line feed at the end. So because this is a 1, this is 64, add them, and that is 65. So now that we know what it actually is, we need to actually push that binary number to the top of the stack, because the print command only looks at the top of the stack. It doesn't actually have anything to push. So step 1 is push A to the stack. The way we do that is we use the stack manipulation IMP. If you remember, that was just a space. And the command for pushing to the stack is just another space. So I'll just say stack manipulation. And then you have another space, and that is the push command. And then the parameter, if you remember, almost every single command takes, in the Whitespace language, takes an IMP, the command specific to the IMP, the parameters for the command, and the fourth one was usually a line feed. I forgot to mention that, but a lot of parameters are binary numbers, and so the line feed is kind of separate from the binary number because it just ends. You can kind of think of it as ending the command. So you have the stack manipulation IMP, you have the push command, you have the parameter, which is just this binary number. So that's 65. So S, T, S, 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 T, that's 65. And then you line feed, and I'll just say end. So that's the first command. Step 2 is you want to actually print the number on the top of the stack. And so the way we do that is we need to use the input-output IMP, and if you remember, that was, the input-output was just, it was tab line feed, input-output, and the print command is just space, space. And I think that's all you need to do, because it doesn't take any parameters, because it just looks at the number at the top of the stack, and so parameters are necessary. So print. And we actually could be done here, but just to kind of solidify the program, it's always nice to actually end it. And so we use the flow control, which is just, what was it? It was line feed, which is flow control, LFFL, and then the command to actually end the program is just line feed, line feed. And so if you actually look at every command, you have this, space, space, binary number, line feed, tab line feed, space, space, line feed, line feed, line feed. So if you think about it, every step, the first command, you go to the specific IMP for whatever command you want to do. then you go to the specific command for whatever IMP you chose. Then you do the parameters sometimes for the command, and then you end it. And that's pretty much how the Whitespace programming language works. If you were to print more letters, you could just redo this over and over again, which is what I might get to in a later video. But thanks for watching.